1 over
All right,
x
these notes and
squared.
examples are for section 5.3 from
Now
your
what's
book.
interesting,
This
perhaps,
section basically only
is that
covers one
u
topic for us. That's inverse functions.
kind of switches.
Um,
Now, the most
so
inside
we
function
can
is
start
x
off and
squared.
talk
That
a
was
little bit about
inside
what inverse
ln.
functions are.
So we do have to multiply by
some
the
other
derivative
properties
of
of
the
inverse
inside
functions.
there.
And
So the
this is
derivative of
not
x squared
just a
is
formality.
2x.
This is pretty important for you to understand.
Since it's a double
what's going
composite,
on
we're going to
here.
have 3
I will
links
say
to the
that
chain
this
rule
topic,
here.
early in my teaching
So
career,
obviously a
I
little
did
bit
not
of simplifying to
like
be
all
done
that.
here. I'm seeing 2
Care for it.
over
Found it hard to
x
remember. Found
times
it even harder to get
ln
my
of
students to remember.
x squared.
Several years back, learned a much better way of teaching.
Okay, number
And
6.
actually, for me, this is now one of the easier things and one of the most enjoyable.
Once again,
I
is
think my
a
students
situation where we have
typically
ln of u, and u is
easy as well.
kind of
Might not
complicated.
feel that way at first.
So
I think it,
the root ln of u is 1 over
Right,
u.
so first question, what are
So
inverse
1 over
functions?
x times ln of x.
Pretty simple definition.
But now we have to
These
multiply
are
by the
simply
derivative of what's on the
functions
inside. That's x ln x. So we go 1
that
d2
undo each other.
plus 2 d1.
Very just kind of an intuitive
So
definition.
I'm seeing
Next two
these
properties
cancel.
are very important.
So I'm seeing 1 plus ln
G
of
is the
x
inverse of F.
over
If
x times
F of G
ln
equals X
of x.
and G of F.
Okay,
Excuse me,
I
G of
am going to
X
skip the section
also
on
equals
logarithmic
X. So in
differentiation.
other words, if you compose
It's not anything that I cover on my test or
functions
quizzes.
both ways and you get
It
X
is not covered on
each
the
time,
AP test either.
then the two functions are inverses of each other.
Another thing
that's
wrong with
really
it, it's actually a
important.
pretty handy thing.
Put a star by this
But
one.
at this point, I want to give you what you
you're going to need
need,
to remember that.
and that's it.
Another thing we said
So
is that
one of the things you might
um,
notice,
it could also be said that between
about
two
example
functions that are
8,
inverses, the
of course, is
inputs
the use of absolute values. And often that causes
And
people
outputs.
some concern, like, oh my goodness, what am I going to do with that?
are
The
exchanged.
truth is
Flip
that
around.
ln
So let's practice that.
in and of itself is,
Probably
only
help you.
is undefined for negative numbers. It's only defined for positive numbers, as evidenced by that graph we saw earlier.
recall that.
Um,
Let's go
you'll
ahead.
see this
and find
expression
the
a
inverse of
lot.
F, and we're going to
The
label
only
that
reason
the inverse
why
of
you
G.
will see that
Um,
is so that
and we'll create a
the
table
negative
of values
numbers
for
can
both.
become
We'll see
part of
how
the
it works as a
domain.
pattern.
Because obviously, if
So
you
I'm
take
going
the
to
absolute
rewrite
value of
this
the
instead
negative
of
number,
F,
the
I'm
output
gonna
is a
write
positive
Y
number, and therefore you could take
equals
the
x
log
cubed
of
plus
that.
1.
So it doesn't
And
really
the way
change
to
how we do
find
the problem at
inverse of
all.
a function.
All right, so if we were
In
going to do
many
this
cases,
problem,
it's quite simple.
all we do
Some
is we
cases it's
say
not.
the inside function is
Don't
cosine of
count
x.
on this.
It's
to
ln
help
of
you find
cosine of
the
x, the
inverses.
derivative
This
of
will
ln.
be very, very challenging.
Let me use a
Some
little
problems are
bit of
going to have.
rotation.
This is simply just to reorient you with what an inverse is.
Derivative.
Here's how you do this. For a simple one like this, you simply flip
of ln
around,
is 1 over u,
Yes,
so that
so
would be
like
1
substitute
over
one for the other. And if you think about it,
cosine
it
x.
perfectly fits this property.
Then we have to
here,
multiply
if the
by the
inputs and the
derivative of
outputs
what
are
was on the inside.
exchanged, right?
So that's
The
negative
line,
sine x.
flip roles. And once
So,
you've done that,
if you wanted to
go ahead and
clean this up a
resolve
little
for
bit, you
y.
get negative
So
sine
the
x
x minus 1
over
y
cosine
cubed.
of x.
And then you cube root.
Well, if you remember your trig identities, actually,
Sides, for
the
negative
cube tangent
root
of
of
x.
x minus 1 is equal
So,
to y.
for those of you
That's the
mathematicians
inverse.
out there,
And
it's
we
kind
were
of a
instructed
fascinating
earlier
thing
to label the inverse
that
as
the
G.
derivative
So let's do that.
of ln of cosine
So
of
right
x
now,
is
this
equal
would be
to
considered our
negative
function.
tangent of x.
and this would be considered the inverse.
And if you take some other
Let's take it a step
calculus
further
courses
and
later
prove
on,
this. Let's make a little table.
you'll look for sure at the reverse of this pattern.
So let's
the
do a
integral
table
of negative
for.
tangent of x.
We're going to make two tables.
The integral,
So
right,
let's
should be
make
ln of cosine x.
a table
Let's see.
for f of x.
So it's just kind of a fascinating combination of different functions,
So
ln,
x
cosine, and
and
tangent,
f of x.
all combined together into one.
Okay, so let's do a few.
All right, so that's all we're going to cover for
inputs.
section
Real simple, let's
5.1.
just go 0.
I think I will push
One, two,
ahead
three.
to do
I'm just gonna figure out the
5.2.
So I'm seeing the outputs as 1.
So we're going to kind of flip this
2,
around now. In section 5.1, we were talking
9,
about
and
derivatives
28.
of ln of x. Section
So
5.2,
now-
we're going to look at not at integrals of ln, but we're going to look at integrals
Let's
that
do-
lead to ln. So based on what we just did,
Inputs
this,
and outputs for
shouldn't be
x
too
and
hard.
g of x. Now
Um,
remember that g of x is the inverse of f.
if the
So we're gonna
derivative
do
of
this time.
ln
Instead of plugging in
is
0, 1, 2, 3,
ln of x is 1 over
I'm gonna
x, well,
plug
the
in
integral of 1 over x would have to be ln of x. And I'm going to write it
1,
like
2,
this
9,
with
and
the absolute
28. I'm going to
values.
plug the
You'll
outputs.
see that is very commonly,
in
and don't forget
my
your plus
inverse.
c. And again, remember,
So let's see what
The
happens.
absolute
If I
values
plug a 1 in
simply
for x over
are
here,
allowing
1,
us
0,
to have
0,
positive
0.
and
So
negative
can you
inputs.
see how the
That's
inputs
all it
and
is. It
outputs
doesn't
are
really
flipped?
affect how we do the
Sure.
problem at all.
plug it in
Okay.
2. 2 minus 1 is
And
1.
then, of
2 minus
course,
1 is 1. So
if
again,
we
you
had
see that
this
pattern
in
of the
composite
inputs and
form,
outputs getting flipped.
kind of the reverse of the
9,
chain rule.
same thing. 9 minus 1
This is
8.
something you got to be really
8 is
careful
2.
of. This is a pattern
If you
you need to be
use
very, very good at. If you
28,
see a
you
fraction,
get 28 minus 1, which is
and
27.
the numerator
27
is the
is 3.
derivative of the
So if you
denominator.
compare these
That's
two,
the kind of-
clearly you can see the
And
pattern.
the integral of that
The inputs and
is simply
outputs of
ln
the inverses are reversed. They're
of u
flipped around.
with the absolute values in there plus c.
Okay, so
We will
using
look
these
at this
principles,
pattern a lot.
plus
The bottom line
the
pattern is this.
principle up
If
here,
you have
I'll
a
highlight it
fraction,
again for you.
if the derivative of the bottom is in the top, or something that we
principle
could turn
right
into
here.
the top,
We're going to talk
then
about how to find the
answer
derivative
to
of
that
just
integral
about
is
any
ln of u
inverse.
plus c. Okay,
Um,
let's do some examples. Again, you are highly encouraged to attempt these on your own, and then watch the video.
So let's do
work
example
along
number
with the video then to make sure
Here
that
we
you
go.
have it.
So this says find the derivative
It's not
of
as
f of
beneficial
a
for you
minus
just
1.
to sit and watch the
This
video.
is
It's not bad. Best thing would be
read as the inverse.
There we go.
Of
All right,
f.
so number one, the
Not
first
f to
thing
the
I would
minus
do is
one.
I would
Something
take
entirely
the 2
different.
out.
So let's see what we can do.
Take the 2 out. You can take any constant out.
You can either memorize this formula that I'm about to show you.
And so, of course, the integral
or
of 1 over
not.
x is just ln of
You
x.
can choose to derive this. It's totally up to you, but we have to start
plus
off
c.
with this.
And the 2 that was there.
This is what makes
still
this
there.
formula at least a little
So
bit
2
easier
ln of
visually.
x plus c.
Is that we're going to say
Hopefully
the
this
inverse
isn't
of
too
f
big
is
of a
equal
jump.
to
If you
g.
remember your log
Okay.
rules,
You have to write
if
that
you were
down. You
multiplying
can't just
log by
assume
a
that the
2,
reader
you can
knows what
actually
you're
move
talking
the 2
about.
up.
So you write that
onto
down,
the x,
and now we can proceed
so you
from
get
there.
ln of x squared, only positive.
Okay.
Right?
So here's what we do.
Well, what
I'm
does
just going to show
squared
you the
do?
formula. I'll show you how the formula works.
Doesn't that turn it into a positive?
We are going to start off with the
And
basic
so, because the
principle,
squared is there, the
basic
absolute value
property
is just
of
unnecessary.
inverse
It's
functions.
not that they
And that is if
cancel
you
out or anything.
compose a function with its inverse,
although if you did include them.
once you simplify everything, you should end up
Number
with
2.
x.
I'll take a slightly different.
So remember, f is our
course
original
with number
function.
2.
And g
Again, you have a
is our
fraction,
inverse.
and you'll find pretty
So,
quickly that
let's go ahead and differentiate
differentiating
this. And notice that it's
fractions,
composite. So when we differentiate, we're going to have to use
excuse
the
me,
chain rule.
integrating fractions
We've done this before.
can be
It's been a
big
little while.
challenge.
But here's,
So here's
the
what I want you to
derivative
notice.
of the left side.
We have a fraction.
f prime
for
of g.
But do you notice
times
how the
g prime.
derivative of the bottom
Makes sense? Do you see how we
is the
multiplied
top,
by the derivative
right?
of what was
The
on the
derivative of
inside?
4x minus
That's
1
what
is
you do.
4.
The derivative of
There it
x is 1.
So what this does,
So remember, we're trying to
perfectly
find
fit
the
pattern
derivative
integral
of
u
the
prime over u.
inverse.
It perfectly
and
fits that.
we actually
So if
already
you
kind of
remember,
have that term where we, or that
Integral
factor where we
of u
want
prime
it.
over u is
Right?
ln
Isn't g the inverse of f?
plus c.
And g prime would be the
So,
derivative of that.
I think
so
this
to
perfectly
finish
fits
off this
that pattern.
formula, we would just write
And
g
so,
prime of x
I think the
equals
answer is
1
ln
over f prime
4x
of
minus
x.
1 plus c.
So this is the formula you want to
You might
arrive
have some
at.
questions about that. You might say, well,
Whether
I
you
don't
choose
think
to
that's
memorize
right. I
that
don't
or
think
just
that
quickly derive it,
that is the answer.
entirely
Well,
up to
what
you.
you can do then is, of course, you can check
Doesn't make
this
much
by
difference to me
differentiation.
either.
So just once, let's do that.
So let's go ahead and
The
figure out this
derivative
particular
of
problem.
ln
So they want us to find
4x
the derivative of the
minus 1
inverse of
plus
x is
c.
3. So
derivative of
hopefully you
ln
realize that what
is
that
1 over
is g
u.
prime of 3.
So that would be 1 over 4x minus
And that would
1
equal 1
times u
over
prime,
f
and that's
prime
4.
of
And
g
of course,
of
the
3.
derivative of any constant, like c there, is 0.
And you
So this
know,
ends
if
up
you're really
being 4
honest about
over
this,
4x
you know, you
minus
look
1.
at this and say, all right, great,
So we
you
can
know, we
check
find
this
g
by
of 3.
differentiation
Didn't
because
seem like it'd be
those
that
two
hard,
match up.
except we don't
So I
have
would
a
say that
function that we
this,
do.
for certain.
And it turns out that to
That's something we'll look at
actually
in the future
find the
is
inverse
if
of
this
that function
4 was
would
not
be
a
very,
4,
very challenging.
let's say it was some other constant, like a 7
best.
or 10 or 9 or whatever.
And
we
so
might
we're
have to
going to
make
have to
some
use one of the other
adjustments,
properties
by
of
either using u
inverses
substitution,
here,
like we
and that is
practiced
that
in
with
section,
inverses, the inputs and outputs are
chapter
switched.
4, section
So
5, I
when
think
you
it
see
was.
g of 3,
Or you
doesn't
could also
mean
think
plug
of
a
it
3
as
in for x. It
where
actually means plug a
the
3
Timmy
in
has
for
messed up
y.
the chain rule, and we need to fix
So
it. Either way,
I figured
it
this out real
works.
quick. I'll
So I
just
think we'll see one of those.
insert
in a
this
little
right
bit.
here.
All right.
So I'll say,
Lost it.
instead of plugging in
Let's
3
go
in
back.
for x, I'm going to say 3 goes in for y.
Let's take a look at number 3.
So 3 equals 1/4 x cubed plus
Okay.
x
So
minus
again,
1.
you have a fraction.
And this
This is probably
potentially
important for me to say it
could be
this
a
way.
major
Not all
challenge
fractions
if the numbers are not
migrate to be
perfectly
ln,
selected,
right?
which I think they
Not
all
all
have
fractions
been.
do. It just
So it's up
happens
to you
that
as
most, if
a
not all of these, will.
mathematician
Because it's in the
to
integral
figure out
1 over u
what
section.
x would
you
have to
So
be in order
be
for
aware
y
that
to
you
be
do
3.
have to
You're just
recognize
gonna
it
do this by
just
guessing and
because it's in
checking.
that section of the book.
My suggestion
You're actually
is
learning
don't
it.
start
Focus
guessing with
on the pattern.
99 or
Okay.
84.
So again, we have a fraction.
negative
And do you notice
1200.
that the
Start
bottom,
small. I mean, these numbers are typically going to be
the bottom differentiated
within,
is the
you know,
top.
plus minus
So this
3
maybe
of
could be,
0.
this is one
You
a
know,
little more complicated.
So,
Set this up.
pause the
So
video
u
if you need to.
equals
Try to figure it out.
X cubed plus
You'll get
x,
good at this quickly.
So u prime,
Keep it to integers. Please don't try
equal
fractions. They're
3x
really big or small
plus
numbers.
1. So you can see that the derivative at the bottom is
Okay,
right there in the
so hopefully you have arrived at the idea that if you plug in
I think
a
this
2,
perfectly
the 2
fits the
works,
LN
because
pattern.
2 cubed is 8,
this would be ln
1/4 of 8 is
x
2,
cubed
2 plus 2 is
x.
4, minus 1 is 3. So I think that
Let's
yes,
see.
x does equal 2.
You can check that by differentiation.
Okay, so that
and
means
I
that
think
g
you'll find
prime
that does
of
work.
3 equals 1
Okay,
over f
number
prime
4.
of
Number 4 is a
2,
little
right? Because
deceptive.
G of 3 is
Notice
2.
that number 4, once again,
Okay,
is a
so now we got to
fraction.
figure out f prime of 2.
Anytime you see a fraction, I think
So
ln
that
is
requires
at
us
least
to
worth
find f
considering.
prime.
Hopefully you're
So
seeing
I'll
that pattern.
insert this in here real
And
quick.
how many times I've
So
said
f
it as
prime
well. So we got the fraction here. Let's
is
check
equal
this to see if this
3/4
the
x squared
ln pattern.
plus
The u
u1.
prime over u. So u
f
would have to
prime
be
of
tangent of
2
x.
would be 4.
And
So I'd say
what
that
would
g
be
prime of 3 is equal to 1/4.
Well, hopefully you remember this from back in chapter 2, I think
And
it
there you
was.
have it.
Derivative of tangent
Okay,
of secant squared.
takeaways
so once
here.
again, this perfectly
Be able to
fits
either
the
derive
pattern.
this formula
So I
over
would say
here
the answer to this
or memorize it. And
is
remember that
ln
with with
tangent of
inverses,
x.
the inputs and outputs are
Plus
switched.
Again, notice I am putting in the absolute values.
Should be
I'm not
good.
saying
So let's
it,
try some more. There's several more examples.
but they're
here.
there. All that does is
try
that
number-
expands our domain from only positives to also
Highly
negative
encourage you on
negatives.
this one. If you
So
feel up to
5
it.
is where things start to
Try
get
it
a
on
little
your
more
own.
interesting. Watch the video.
Okay,
Feel
whether
free
you
to try
memorize
these
it or
on your
not,
own. I think that would be a valuable
here's the
thing for you to
formula. G prime of x
And
is equal
we
to
can play
1
games with
over
that. But let's look at number
f
5.
prime of g of x.
Once again, what do you see? Do you
They
see
want
the
us to find
fraction?
the
Of
derivative
course.
of the inverse.
Anytime you see a
7.
fraction,
Let's
you
not
need to
forget
at
that.
least consider ln. It won't always be ln.
Let's not forget that
At
the
least
inverse of
consider it.
f,
So let's
we're going to
consider
set
that
that equal to
seriously here.
just for notational purposes only.
If we're looking for the u
Okay,
prime,
so g prime
of
over
u
7
pattern.
is equal to 1 over f
u would
prime
have to
of
be
g
x
of 7.
squared plus
Simply
2x.
plugging
Right?
in a
That's the
7
bottom.
for x. That's it.
And then u prime would
So
be
finding g of
2x
7
plus 2.
means that 7 is actually
Well, of course, this is where it appears maybe we
so
can
7
make a
equals
roadblock
2x
because the
cubed
top
plus
is
5.
not u prime.
This one's a little bit easier.
The
to
top
find,
is
of
x
course.
plus 1. So what you're encouraged to
so
notice
assuming
here
1 is equal to
is
x.
that the top is only off by a factor
Okay,
of
so
2.
g prime of 7
So I'm allowed to
is
fix
equal
that.
to
So
1
what I'm going to do is I'm
over
going to multiply the top by
f
2.
prime of 1.
I'm going to do that. I need to multiply the
So
outside.
we've got to
by
find
1.
f prime now. So
Once
let's
I've
do
done that,
f prime is equal
this
to
does perfectly
6x
fit the u
squared.
prime over u
You
pattern.
plug in a 1, obviously you get
So,
6. So
the
g prime
answer
of
would be
7
1/2 ln
is 1/6.
x squared plus 2x.
Hopefully you're getting the hang of this.
Plus
Here's a couple more examples.
a number of ways that could be manipulated, but
All
I
right.
think that's fine.
Number 3.
As is for now.
Again,
Obviously, this can be
memorize the
checked
formula,
by
derive it.
differentiation.
doesn't particularly matter to
if
me.
you
Just
wanted
remember
to
that g prime
do
is equal to 1
Full-on
over
u substitution.
f prime of g.
Certainly could.
of
Maybe
x.
we'll do that with number 6.
And that will hold true if we define the inverse of f to
Okay,
be
so
g.
take a look at number 6. A little simpler.
All right, so we're supposed to
same concept,
find the
though.
derivative when x is negative
Once again,
15.
fraction, right?
So that would be g prime
So the integral of
negative
1
15
over 3x plus 2.
equals 1 over.
So let's
f
think this through.
prime
The derivative of the
of g of
bottom
negative 15.
has to be in the top if this is going to fit the u prime over
Well, this
u
is where we
pattern.
need to write negative
So,
15
u-
equals 2x cubed plus
Let's
x
do u
plus
substitution.
3.
Let's just do this.
Again, encourage
u
you
would
to
have to
stop
be
this
the
if you haven't already
So u would be
and
3x
think it through
plus
as to
2
what x would have to be in order
du
for this equation to work.
would be 3 dx. So when we attempt to integrate here,
All
by
right,
substitution of u,
Just thinking about it quickly, I'm
u
thinking
is
it's
equal to
negative
3x plus
2.
2.
Let's
So I'm
find out.
saying 1 over.
We'll plug in a negative 2 and get negative 8, so that would
And
be,
du equals 3
negative
dx. So to make
16.
this work,
yeah, it's going to work.
we're going to have
This
to
is
divide
negative
this
2
by
plus 3. That's
We're
equal
going
to
to get
negative
dx
15. So
equals du,
I'd say that x is
and
equal
then
to
I will
negative
put
2.
the over 3 out front.
So g prime of
And you
negative
can see this
15
perfectly fits.
equals 1 over f
u
prime,
prime over u
negative 2.
pattern now. So it'd be 1/3
Right, now let's find f prime.
ln of u.
f prime is equal
Let's
to
see.
6x squared
Whenever you
plus
do
1.
u
So
substitution,
if you plug a
then
negative
the
2 in
integral.
there, looks like you're going
You're
to
gonna plug back
get
in.
25.
So it'd be
So g
1/3
prime
ln
of negative 15
absolute value
equal
3x
to
plus
1
2. Let's see.
25th.
It could be done by just
Alright, getting the hang of this.
gauging the
Hopefully
error
we'll-
in the chain rule, fixing
Alright,
it by
let's
factor
look
of
at number
3,
4.
or you could do substitution like I
Number
just did.
4, our last one. It is.
Okay, let's apply this to finding area.
So at number 4, again, this should feel very repetitious. It's the same thing over and over again.
So, number
Just different
7
numbers,
says
different
find the
scenarios.
area of the region
Same
bounded by
skills,
the
though.
graph of y
Alright, so
equals
again,
x over
your
x
formula,
plus 1, the x-axis and the line
g prime
x
equals
3,
1
which
over
of course is a
f prime of
vertical
g
line.
of x.
You can check this out on
It's
your own
true
if
if
you
the
want.
inverse of f is equal to g.
The graph
So we're supposed
x
to
over
find
x
this
squared plus
to remove
1.
the inverse when x is 0. So that would be g prime
Approximately
of 0 equals 1 over f prime of g of 0.
like this. And so we are asked
means the
to
output is
find
0.
the area of the region bounded by the graph, the x-axis, and the
So
line
we gotta
x
do a
is
little
equal
bit
to
of
3.
Arithmetic in our heads, perhaps.
So, you know,
On
x
paper,
equals 3, we
whatever.
have a vertical line.
Figure out what
We're just going to say is
x
right
would have to
about
be. Have you
there.
figured it out yet?
So,
It's
it's
1,
not the
isn't it?
greatest worded question.
X would have to be 1.
Um,
So g prime of 0
At this point, let's just
is
consider
equal
the
to
area
1
that they're
over f
describing to be
prime
that
of
area
1.
right there.
Again, g of
We
0
do
is 1.
cross
So just put
through
1 where
the
g of
origin
0
there.
is.
Your x-intercept is there at
Okay.
0.
So now let's find f
So
prime
setting
to
this up,
finish this off.
The area
So that would be 10x to the
is
4th
equal to the integral
plus
from
4.
0
So
to
if we plug in a
3
1, you get 14.
of x
So g
over
prime of
x
0
squared
is equal
plus
to 1 over 14.
dx.
And that's that.
Okay, so once again, we're attempting to find the integrated
Okay,
fraction.
I think we'll stop this
Certainly
video
worthwhile
here for now,
to
and I'll do
consider
5.4
ln
in
as
a
a
different
possible
section.
solution. So